Hi, this is Keenly, and let's talk about one more way we can use the conservation of momentum, and that's with explosion problems. Now, in physics, an explosion doesn't have to mean something actually blowing up. It could be where any one object separates into two or more other objects. And so it could be where, like in this picture, I've got a spring that's going to separate these two masses. Or it could be just one person pushing off against another one. Or it could be something like this, where we have a cart, that little plunger right there, another cart, they're held together, and then when you let go, they separate. And so that would be a good example of explosion. And so it doesn't have to be where something actually blows up. It could just mean one object is separating. And so for this example, we're going to set some parameters to this video. That the two objects are sitting still at the very beginning, the explosion happens, and then the two objects are going to move off in opposite directions. So our generic equation is going to be this: 0, because the total momentum of this system is going to be 0, equals the momentum of the first object plus the momentum of the second object. Again, the total momentum of this is also going to be 0. And the reason why is because if one object's going one direction and one object's going the opposite direction, we have to say one way's positive and the other one's negative. Traditionally, we say right's positive and left's negative, but we don't have to go by that tradition. So let's look at just one example of this. Here's a very basic one. We've got a gun, or it could be a cannon, or like I said, it could be just two people pushing off of each other. It doesn't matter what it is, but we have one object together. So we got a gun with a bullet in it, and the gun fires. The bullet leaves the gun with a velocity of 300 meters per second. What's the recoil? That recoil is that kickback from the gun, recoil speed of the gun. So again, I like to start off with a picture. It doesn't have to be a good one. Mine never are. So there's the gun and the bullet. It goes off, and then the gun, which is 4 kilograms, should go one way, while the bullet, which is 0.06 kilograms, is going this direction at 300 meters per second. So, setting this up, again, you can just use total momentum before equals total momentum after, but we can also use that generic equation. So 0 equals the mass and velocity of the first object. You can put a prime there if you want for after the collision or after the explosion, but you don't have to. Plus the mass and velocity of the second object, again, with or without the prime. So everything starts off sitting still. We've got a 4 kilogram object at some velocity we don't know, plus the 0.06 kilogram object traveling off at 300 meters per second. So doing the math, we can do 0.06 times 300 gives me 18. So 0 equals 4v1 plus 18. Move the 18 over, so a negative 18 equals 4v1. And then we just divide by 4. And we get 4.5, negative 4.5 meters per second is the velocity of the gun after the explosion. Now, think about this. Think about if somebody was holding that gun, they got it pressed tight against their shoulder, then you would be adding your mass to the mass of the gun. And so then the total mass of this is going to be much, much greater. So that means the velocity that comes back is going to be much, much less. And that's why when you see in movies people shooting rifles or guns or any type of these shows, they always have that gun pressed tight against their shoulder so that it minimizes the recoil. All right. Thank you, and have more fun with physics. Talk to you later. Bye.